Hello. In today's video I will be talking about merge sort. I will give a brief introduction before working through a short example showing the pseudocode and touching upon a few practicalities when it comes to merge sort. So just a brief introduction into merge sort. Merge sort is typically thought of as a recursive algorithm, though there is an iterative bottom-up version that's probably more suited for real-world use, and it solves the problem through a process known as divide and conquer, where we split the overall problem into smaller and smaller sub-problems and tackle those before merging together to solve the overall problem. In the case of merge sort, we recursively split the array into half at each step, and then we merge the arrays back together in sorted order. Let's now take a look at a small example. We have an array consisting of 8 elements and is currently unsorted. The general approach with merge sort is to split the array in half at each step until we have arrays consisting of just a single item. So we divide our input array into 2, and then we divide those again into 2, and then we divide those once again into 2, giving us 8 arrays, each consisting of a single element. At this point, the first stage of merge sort has been completed. We have taken our input array and we have recursively split it in half, giving us a total of 8 arrays, each consisting of one element. Let's now take a look at the merge stage of merge sort. We have our 8 arrays, each consisting of a single element, and as we're working back up the tree, we merge these into 4 arrays, each consisting of 2 items. We compare as we go, inserting the smallest item each time. So we compare 5 and 2, 2 is less than 5, so we insert 2. There's only 5 left, so we insert 5, and that gives us our first array of 2 elements. And we repeat this process. So we compare 6 and 1, 1 is smaller, so we insert 1. We've only got 6 left, so we insert 6, giving us our second array of 2 elements, and so on. Once we have our 4 arrays of 2 elements, we then again work back up the tree, merging into 2 arrays of 4 elements, keeping it in sorted order. And then finally we take those 2 arrays and we merge it into a final array of 8 elements, giving us our output in sorted order. Let's now take a look at the pseudocode for merge sort. There are 2 functions in merge sort, the actual sorting step and the merge step. In the sorting step, we recursively divide our array into half, a left-hand side and a right-hand side. If the length of the input array is less than or equal to 1, we simply return. This is our base case. We then sort the left-hand array, we sort the right-hand array, before finally merging the 2 arrays into our output array. The merge step works as follows. While there are still elements in both the left and right arrays, we compare the current item in our left array and the current item in our right array, and we insert the smallest into our output array, and we increase the index appropriately. Once the first while loop is finished, we may still have unprocessed items in our left or right arrays. in which case we just add those into our array directly. Now let's take a look at the time and space complexity for merge sort. In the best case, average case and worst case, we have O n log n time complexity. And this is because we repeatedly split the array in half at every step, and we then merge those n elements back together to form our final array. We also have O n space complexity, and this is because we have to have an additional array where we can merge our elements back into. Consider that insertion sort and selection sort are in place, and they have a space complexity of O1, or constant space complexity. If space is at a premium, you may wish to use one of those. In this video, I've also demonstrated the recursive version of merge sort, and this has the additional overhead of repeated function calls. It may be worth using the iterative bottom-up version of merge sort to increase performance. And finally, if the array is likely to be small, say 10 to 20 elements, you may wish to use something like insertion sort. As always, thanks for watching. I hope you found this video to be informative and useful. If you have, please hit the like and subscribe buttons, and I hope to see you again in a later video.